welcome to our closing panel. My name is Ben Rush. I'm a postdoc in radiology, and I have the honor of being the moderator for our closing panel. And throughout this bazaar, like our reputation for data science, like we've been partying pretty hard. So this is how we're going to end it with a closing panel all about data science from past to present. This is data in action. But of course, we are going to thank our sponsors to start. Maybe. Of course, Zoom will get in the way. All right, there we go. Okay, we've got our code of conduct. So I think this is not only good for the last hour and 15 minutes of the bazaar, but going forward too. So if you want to keep being friendly and polite, welcoming, respectful, and mindful and kind to others, please do so when you're asking questions and talking to others. Thanks to everyone who's been putting so much energy into the Research Bazaar. I've had a delightfully wonderful time talking to new people, presenting some of the stuff that I've been doing, having this opportunity here. So I think we should do one last round of applause for the planning committee because they put so much energy into it. So thank you, planning committee. And also just a really cool reflection to see all these different departments and people coming from different backgrounds, because that's the power of data. We're intersecting in so many different ways, as we'll hear going forward too. And of course, thanks to our sponsors, and this couldn't happen without them. So hopefully I had some time to talk to them yesterday. I think some are still around. And for graduate students, undergrads, potential employers, we're going to talk to them, and also collaborators as well. So thank you, sponsors. And this would not be possible without a grant from the UW-175th. Let me make sure I get the title right. From the Office of the Chancellor for providing a UW-Madison 175th anniversary grant for this session. And we will actually go back into history to see what data science was like on this campus and then look forward to. So it's really neat. And I will start to introduce our panelists. And we've got, like I've been saying, we've got a really interesting panel. I spend a lot of my free time talking about science communication and doing stuff out in the community, storytelling, comedy. So I'm also really excited to get these perspectives because there will be a mix of both data and stories in here too. So really communicating what data can really do for all different sorts of people. So to start, and we are not in any particular order here. So if I call out your name, if you could raise your name, panelists, that would be very helpful for everyone involved. We're going to go down to my direct left. We have Florence Shaw, who is the David Hall and Margie Devereaux Professor of History of Physical Sciences in the Department of History, the Associate Vice Chancellor of Research in Arts and Humanities, and the Associate Dean for Graduate Education, a historian of science. Her current research centers on the long history of data practices in astronomy. Pretty cool. That's just our first panelist. All right. Then, not going in order, on the other side, we've got Corinna Gries, who is an alumna distinguished scientist at the Center for Limnology. She has spent her career of over 35 years providing a foundation for data science through making data accessible and reusable. Most recently, she has curated data for the North Temperature Lakes Long-Term Ecological Research, LTER, site and ran a data repository through the Environmental Data Initiative. All right, going back to the other side of the table, we have Allison Kittinger, who is the program manager at the newly formed Open Source Program Office, or OSPO, in the Data Science Institute. Allison is passionate about open science, especially fostering open scholarly infrastructure. She works to grow open source software adoption and connect with open source communities on campus. And if you have interest, she's more than willing to talk to you about it. Okay, going to the opposite side of the table again, we've got Will Fulwider, and I stumbled there because I always want to put a Wilder in your last name. That is not the right way to do it. Will is the regional crops educator for Dane and Dodge County Extension. He works with farmers across the two counties on field and forage crop production. Prior to joining Extension, Will worked with grape growers in California, diversified coffee farmers in Kenya, and rice farmers in China. And then now going to the middle of the table, we have done it. We have Sol Kim, who's an assistant professor in the Department of Computer Science at the University of Wisconsin-Madison. That's here. Her research interests lie in the intersection between HCI, visualization, and data science. She is interested in developing tools and algorithms to help people with varying abilities interact with data and visualizations. So the way that this will go, we're going to go and ask a single question to each one of our panelists. That's going to be about 45, 50 minutes. And then while they're discussing kind of their perspective on data science, their stories, there will be QR codes like this up, which you can look at and then submit questions. And I'll magically be fed those questions for you later on. And we'll have about 15 or 20 minutes to do that. So we'll go ahead and proceed. We have unique questions for each of our panelists. And we will get started with Florence. So Florence, as a historian, can you give us a sense of how scientific data has changed over time as people have tried to make sense of the natural world, and how scientists have worked to make data from different sources talk to each other?
Okay, so I have a slide.
You do have a slide, and I should have put that up. Thank you.
And Ben, yes, I can answer your question. So I'm going to take my time to give you a super brief tour through some highlights in the history of how data has been used in the case of astronomy, which is the one I know best. So starting in the upper left-hand corner there, you see a clay tablet that was probably copied sometime in the 600s before the Common Era. The data on it probably were compiled maybe 400 years earlier, so maybe a millennium before the Common Era. And it consists of things like lists of important stars and constellations, the dates on which those stars become visible in the eastern horizon, before the sun rises, the asterisms or the constellations that are in the path of the moon, and so on. And so this kind of data is clearly cumulative data, right, done over a long period of observational time. There's no dated observations on this text, but not only does it represent the accumulation of many, many generations of star watchers in ancient Babylonia, but it's also a text that is still extant in many different other clay tablets from the 600s before the Common Era until maybe the 300s before the Common Era. So this text lived on as a repository of, again, accumulated data, empirical observation for at least 600 years, if not more. Many other clay tablets have not survived for various reasons, but I think it's a really good representation of the efforts of people who lived a long time ago and how they tried to preserve data for future generations. Then coming to the lower left-hand corner, lower left-hand corner, you see a page from a calendar that was computed and then printed by a man named Johannes Stoffler, who was the first holder of the chair of mathematics at the University of Tübingen, the same university at which Johannes Kepler got his degree. You may know that name. But Stoffler was probably one of the most experienced and well-known computer of astronomical tables in his time. And in computing his calculations, making those calculations for planetary positions over the course of, I think, maybe a 20 or 25-year period, he was using models for planetary movements that had been devised, let me think, 1,200 years earlier by the Greek and Roman astronomer Claudius Ptolemy. So Ptolemy was working in the 200s of the Common Era, or no, 100s of the Common Era, working in the city of Alexandria in northern Africa, close to Cairo. And Ptolemy was relying on what kind of data? He used Babylonian data. So he cites Babylonian material, probably not directly from clay tablets, but probably through compilations that had been remediated from one surface, clay tablets, and one form of archiving to another. He was probably using materials written on papyrus, made from reed plants, written not in Akkadian, this language or in that script of cuneiform, but writing in Greek. He was also still using Babylonian units, such as a base 60 system, which the Babylonians devised for their purposes, and he continued. But he was using probably an alphanumeric system for writing numerals. So he didn't write numerals the same way. And later, people who used Ptolemy's ideas like Stoeffler would have to translate his number system from an alphanumeric system in which, I don't know, let's say alpha equals 1 and beta equals 2. I don't know the details, but something like that. Translated that into different numbering systems, such as the one that Copernicus, upper right-hand corner, used, which was Roman numerals. So if you can imagine doing any kind of computation using Roman numerals, I mean, even addition and subtraction, not to mention other kinds of more complex arithmetic operations, that's a bit of a challenge. But what you see in the upper right-hand corner is a page from actually not Copernicus's own work, but a guide, basically a kind of manual or a guide to Copernicus written a few years after he published his book in 1543. And I would ask you to see if you can notice in those many lines of printed text, if you can find the empirical data which is there. If you think it's hard to find, not only because none of us, including me, read Latin, one of the readers of this book in the 1500s basically had to go in and say, here's the first eclipse. So you see the red annotations in the right-hand margin. What it says is first prima eclipsa, second eclipse. And so he's highlighting, this reader's highlighting, here's some of the empirical data that Copernicus was using. And some of that empirical data goes back to the Babylonians, which was cited in Ptolemy's work from the 200s. So you already have couple millennia's worth of basically data that has been accumulated over time. And then finally, in the lower right-hand corner, you see the cover page of NASA's 5,000 year canon of solar eclipses. So basically, this is another set of computed data, which shows basically the dates and positions of the moon for eclipses as seen from Earth from 1999 before the Common Era through the year 3000. So I give you these examples just to illustrate some of the challenges that astronomers over many, many centuries wrestle with. First, in moving from one material support to another, what do you do when your clay tablet dissolves or is broken? This tablet probably was pieced together by very patient people who knew what they were looking for and could put together broken pieces of tablet, maybe uncovered in very different archaeological sites. Then thinking about what Ptolemy had to work with in his time period, the copies that were made of his work, sometimes only visible through X-ray or other kinds of modern technology because they were written on very valuable pieces of parchment that later folks thought, we're not so interested in the many, many pages of tables. We're going to scrape off that text and write something else on top. And only through various kinds of modern day imaging has, for instance, some works by Archimedes, a well-known Greek mathematician, become known to us because it's sort of invisible to the naked eye. But then thinking about more modern challenges, what do you do when you go from paper to magnetic tape, which I think was the preferred medium for astronomical data in the 60s, 50s, 60s. So I think that Voyager 1 and 2 still use 8-track tape to record their data and send it back to NASA, and they're still transmitting, right? I think there's maybe an alignment issue right now, but they're still out there collecting their data. Glass plates, which were used by observatories in the late 1800s, early 1900s, which have been, and today there's major archiving projects to image those glass plate images of the skies as they were photographed in 1893 or whatever, and use that information now. So again, super fast, quick trip through different kinds of forms of data. And the last comment I would make is that on this slide, you see, I think, some of the real differences in treatment and ability of astronomers in particular to treat empirical data versus computed data. computed data from a very early point, let's say Ptolemy in the 100s of the Common Era, was already put in tabular form because it's based on algorithms. You know what your variables are going to be. You know what you're looking for. Empirical data, very hard to wrestle with, as I'm sure many of you have personal experience of. And the fact that Copernicus embeds his empirical in the upper right-hand corner into basically prose, and that needs to be laboriously extracted by readers, I think is a real indication of the difficulties of trying to get empirical data into as nice and tidy a form as computed data has long been. So I think I'll stop there. Yeah.
Cool. Yeah. Thanks for sharing that. We're going to jump a little bit closer to home with Corinna. And Corinna also has a slide to tell us. And again, if you have questions, you can look at that QR code and ask them.
All right, yeah, just a little closer. I'm still have been around for a long time, and I've been trying to make data available to a larger accessibility to start with, to a larger community, to more researchers as my career. So as you can see, I've tried to date myself here. And yes, I did start in DOS. I did start with the early databases that only came in the DOS systems. And I have really focused on two related types of data, but they are different and they have always been posing sort of different issues. The upper sort of timeline you can see there is biodiversity data, mainly natural history collections data. So everything that you find in a museum, you find in jars, you find in drawers, smashed down, stuffed, however these things are being kept. But all of these natural history collection have label data. And so very early on, we started to digitize these label data. And from there, so you can see two herbarium sheets up there in the middle with their data associated. So there was a lot of manual data entry in the beginning until we got into photos, OCR, all of these kind of technologies that we could use to speed up that data collection. And then by now end up on the upper right side there with very impressive distribution maps, data that can be used for predictions, for climate change analysis. And we are looking at natural history collection specimens that have been collected for a very, very long time. So even in this country, we have those fairly well preserved specimens going well back into the 1800s. In Europe, they go back a little further. So the other major group of data that I've been working with is what we call the environmental data. And those are more observations, measurements. And here I've been concentrating on what we call the long-term ecological research, which is an NSF-supported program with sites in the United States. Right now, I think there are about 28 different sites, and they range all the way from the Arctic to mainland US, down to Antarctica and French Polynesia. So there are a few examples here of how these data are being collected. And on the lower left side, you see a couple characters that you may recognize. One is Edward Burge, and the other one is Burge and Jude in a boat. And we here have one of these LTR sites, which is the North Temperate Lakes LTR, and we monitor the 4 lakes around here, around Madison, and then 7 more lakes up north around Trout Lake. And so limnology as a field has been sort of invented in North America by Burge and Jude. And yes, we have been looking at their index cards where they have been collecting the first data about our lakes all around here, and they are now all digitized. They all are online. They all are in our Environmental Data Initiative, which is the data repository that holds all data for these LTR plus many other research projects in the environmental sciences. So one major difference between these two groups of data is that these ecological data are highly varied. So every data set comes in a slightly different format. The semantics of how this is being described is always different. You can hardly get anybody to agree on keywords for finding these data, much less how to collect them, how then to organize them into a data set. So we had to come up with a lot of social institutions that did a lot of talking about standards, what we can do. You may have heard about the NEON program, the National Ecological Observatory Network, which really came out of this whole big mess of data where people thought we need this institution that can collect data across the United States in a standardized way so that we really have a few data that are covering the whole area. So the way I'm seeing it is NEON collects the wide, flat, small, little bit of data. LTR sites collect the site-based deep knowledge that now our whole challenge is to connect it, to use data science, to be able to learn from both the deep knowledge that comes with working at a site for a long time, knowing the people that live there, knowing what they do, knowing what they change, what goes on. And so on the right side, between the data collection, many social interactions, a lot of talking, a lot of standardization, a lot of agreements, we now are able to show that upper right portal of a lot of collections, observations, and in the lower part, we now can really see how Lake Mendota has been freezing over the last 100 years.
Well, I feel like you have the perfect segue into Allison's talking about open access data. Allison, I will get your slide up and it can be your time to shine.
All right. So, yeah, I think we've heard some really amazing examples of how practices have evolved throughout history. And I think what I wanted to address is kind of in between these two time periods. And so this slide represents one of the first scholarly journals published by the Royal Society, which is one of the first scholarly societies in the 1600s. And I wanted to put, one of the first issues of that journal in the 1600s alongside one of the latest ones with a cover that was, digitally created and digitally published. And I think that really illustrates how, in many ways, a lot has changed in the world of sharing research, but a lot has also stayed the same. It's still published by the same society that still exists today, even if maybe the format has changed and, there's software underpinning what's going on. But, thinking about that first journal and the advent of societies, that was really a major revolution in the 1600s of open science. Before journals existed in the Western world, wealthy patrons with their own, agendas and designs on research were funding things. They were the main sources of it. And sometimes that funding ran out. And, researchers realized that it takes a lot of sustained funding and that, they might come to conclusions and questions rather than answers and things that might not fit So they decided to create societies and pool this funding together and share their research in publications. And that really opened the door for a lot of scholarly collaboration in that sense. And a lot of these societies still exist today. There's societies of all kinds of disciplines and fields and things, including the Royal Society, which now this journal has been split into 2 different journals to cover all of the fields and advances that have been happening. So after that, these societies and these groups still exist, but then, later on you have the advent of commercial publishing and commercial publishers coming into this space. And now there's a coexistence of society publishers and commercial publishers. And that, changed some things along with the internet. Of course, the internet changed everything, right? So these 2 things sort of coincided, and the internet and technology have at the same time, revolutionized discovery and access to this research. It's a tool to, sort of execute immediately what this first journal was trying to do. With the click of a button, you have all of this information. And it changed what we study, how we study it. The internet is both a method and also something to study, right? We look at how it works and, software, and, we use software to do research, but we also research software, and it's a whole ecosystem. As new technologies are created, so are new avenues of discovery and things like that. And that's something that's really exciting to me. But the internet isn't necessarily completely free in the financial sense. The most simple example of that is you pay for internet, right? You have a provider, and a lot of, the publishing industry now, with its sort of advent of commercialization, has, created digital distribution costs and, bundles and big deals and things that have created new structures of cost and funding and things in the scholarly enterprise. And, this sometimes limits access to only well-resourced institutions, and types of research outputs like software might not necessarily fit into this structure. And you hear, librarians say we're in a serials crisis with inflation, as a former librarian. So, and maybe you've heard about issues with reproducibility, and so there's consequences and side effects of all of these decisions and how we share and produce knowledge. So I would say that, of course, open science holds promise as another player in this ecosystem. I don't think we need to, eradicate everything. I think that a monoculture of one type of publishing is just as bad as a crop monoculture. You want diversity in in what you're doing, and not all research can be open, but I think there's a lot of research that could be open but isn't. And open science, the ability to openly share research products, to share findings, and to collaborate with each other in a public, open manner, holds a lot of promise going forward. And it's something I've seen a lot of interest in, both as a method, but also as something to study and something to discover. So a facilitator of open science, has been grant funders, the federal government. You see, major funders requiring you to share your data, requiring to publish open access, things like that. And, to have an ORCID or something, that is sort of a signal of open science and wanting to, share the results of, what you've been working on with the greater public. And, I think about the most recent Office of Science of Technology policy, the OSTP memo that came out. I was a librarian when that first came out, and It really made a wave, I think, in the way it spoke about openness. It cited it as a catalyst for public awareness, policy influence, discovery, knowledge equity. It gave the example of the COVID-19 pandemic as an example of how, rapid sharing of research and open publishing accelerated discoveries and solutions. And I think the latest frontier of open science and this sort of ecosystem that a lot of you are already participating in is software. So, you think about the internet and digital publishing, it's all, run on top of software, on top of code, on top of programs people have created. And it's not only increasingly a goal of research, but it's also a method. It's a byproduct. You might not set out to create software in your research, but it might be something you do to solve a problem in what you're doing, or get to the next step. And so it's really something that can be used in every part of the research cycle. It can enter at any time. You might find yourself interacting with software, even at the very end if you're publishing your work digitally. And I'm not sure necessarily yet if academia as a whole, in like the broadest sense, has really caught up to treating software as a research output, as a research process. I think we made a lot of strides, but when you think about open access publishing models, data sharing models, imperfect as they may be, we're still iterating on those as well. We're still working on ways to support the publishing and sharing of software in a similar way that fits within, this publishing structure that we all know and operate in, and that as a result we get, rewarded, incentivized, et cetera. So I'll share that I was at a meeting of like scholarly communications and research infrastructure supporters and practitioners recently, and we discussed, what is the cutting edge of our field and what is sort of dusty or outdated. And someone put software on the dusty side, and I was like, what? Software's dusty? It's news to me. But what they wanted to say with that is that the software itself wasn't necessarily outdated, but maybe the way that we treat it is, and the resources that we have for, supporting the use of software in research perhaps are a little dusty, and that, we should focus on that both, as a publishing mechanism and as something that more and more people are using in research. So especially as, funding programs catch up and, require sharing of other research products like data and open access. There are now programs for sharing software. There's NSF programs for open source ecosystems, software that's openly available, and sharing that as a part of the research lifecycle and open science practices. And so as AI, advances, technology is increasingly sort of intertwined with data science. I think they're becoming increasingly inseparable of, data science, software, technology. All of these things are sort of operating in the same sphere. Open source models for research software are crucial to continue this tradition of collaboration and knowledge sharing that have, been started by these very first scholarly journals that people created to do that, exactly that. So, this is also what I hope to do here at UW-Madison with all of you in my brand new open source program office, to work with you and campus and the community to support, sustain, and advocate for what's possible in research and technology going forward. Thanks.
All right, thanks. Yeah, I feel like we've got a good history framework and kind of what's going on in the modern day. Now we're going to transition to the actual application of some data science projects with Will.
I'm not a data scientist. I'll be the first to admit that. I work with farmers.
I'm not either, it's okay.
I work with farmers in my role in extension. But one of the things that I do in my role is I do a lot of on-farm research, working with farmers to figure out the issues facing them in their agricultural production systems, and what are the questions they have that they want to answer. And so on-farm research is a tool for doing that and bringing the university to the farm fields themselves and helping to feed kind of what is the university approaching in the research that we're doing, which is the whole goal of extension. So I really see on-farm research as like what extension should be doing within the agricultural sector. But a lot of that on-farm research gets produced into a PowerPoint, and it's great. You present it at a conference or at a workshop, and then it lives on your PowerPoint forever until you turn on your computer when you're done. Like, it doesn't go anywhere. And that's because, again, I'm not a data scientist. I work with farmers, and that's everyone else that works in my role in extension. So what we've tried to do is try and throw something together to create a home for this on-farm research. There's many reasons why, and I'll get into those in a second, but it kind of looks like this. It's not super sexy. I'm not going to be the first, I'll be the first to admit that, but it's an attempt. I'm not a data scientist, and this has no budget. So this is what we've created. But it's a filterable, searchable database for the research that we do with farmers. And some of it's highly replicated. There's six replications, and there's all these different treatments. Some of it is not. And, how do we put together a database that gives, time and space for all these different approaches? But lets people know that, this may be not as trustworthy because it has one replication as something that has four. So trying to figure out some of these issues and how do we, present this data also in a way that's digestible. Because this isn't for me. I mean, it is partly, but it's also mostly for farmers and crop consultants. So the public, how are they using this? How do they approach this? How do we design it so that it is sexy, it is usable, people are attracted to be able to use it? Has been a lot of what I've kind of been struggling with. But one of the challenges that we have in putting this together is this spectrum of anonymity versus granularity that I see with some of these reports of this on-farm research. Farmers are the most surveyed population in the United States. They answer a lot of surveys that get into their mailbox. They are talked to a lot about different things. And they want to protect their data. And as they, advance in technology, they get more and more data about their farming systems. And some of that is, sensitive. We deal with large landscapes in which we're applying nitrogen at high rates in order to be profitable in these systems. And that nitrogen doesn't always stay in the field. It sometimes leaves the field as in the form of nitrates, which could be harmful to human health. I'm not like excusing farmers for that, but it is part of the system, right? And so it's like, okay, if we're doing research on nitrates and we're publishing this and the farmer's name is on it and the field is tagged with it, what does that mean from a regulatory standpoint? So in our approach and design this, I would love to have had this map up there, which is kind of small and really, really skinny for some strange reason. That's the way it looks. It's not just the photo I took. To have points all over the map that show the different fields and you can see what your neighbor's doing, because that's part of the point of this, is to inspire other farmers, right? Is to see, what are my neighbors doing? What's cool? What's different? How can I push these systems forward? How can I use less nitrogen, use less phosphorus in my fields, ramp down that, increase my profitability, decrease some of that environmental kind of impact of my farm? And so how do we do that without singling people out? That was kind of at the beginning, a big part of this question, which is why we have these counties outlined rather than single points on that. And that was a big question. It seems like a simple solution, but we're like going back and forth. How do other people do it? So that was kind of one of the big challenges that we ran into initially. And also making sure that the farmers are comfortable with them being like, this is X farmer's project that he did, and the results aren't going to always be what you want them to be. So what does that look like? And I think one of the big opportunities with this, like I mentioned before, is other farmers finding not just inspiration about trying new practices, and crop consultants as well. Crop consultants work with multiple farmers. They have a kind of more wide-ranging effect. They do a lot of on-farm research. So working with them to put some of their research that they're doing on farms, because I'm only one person. There's a lot more crop consultants in the counties that I work in than there are of me. Working with them to put some of their research on there. And also producing a report, which I didn't put on here what the report looks like. It's also not that sexy, but it works. As to methods, how do you do on-farm research that has a science basis? That's what we're doing in Extension, is creating science-based resources for farmers. And so while most farmers, if they want to try something out, throw something on one side of the field and something on the other, and they're like, that did well, that's how I'm going to put all 4,000 of my acres into production. Sure, maybe that's that one year that it does really well, but we need multiple years. We need replications. We need it randomized. These other things that, are a little bit maybe not as approachable to someone that, their background is in farming, not necessarily in research. So a big part of this is just showing people what are some methods to doing on-farm research and answering those questions that they have about their production systems.
So we've got a little time for your section left. Could you talk a little bit about how you've engaged with farmers to try to get them connected to a database?
Yeah. So, I mean, this is in a super nascent stage. Again, not very good looking, but it's taking this out to, I have a lot of farmer meetings where, it's an annual conference of a farmer-led group and presenting this and being like, hey, we're working on this. What do we need to do? Sending it to crop consultants that I work with a lot with to be like, how do we need to change this to make this more approachable for a farmer, and trying to have it more of an iterative approach rather than just like plonk, here's what extension thinks you need, which is, a very hierarchical way of doing it, which is not the way that we're supposed to be doing it within extension. It's supposed to be a little bit more grassroots than that. So, working with them on that, and also at some point feeling comfortable with like, okay, we don't have that much data in here. We're all doing this on a very, 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 very part-time basis. Like I said, no budget. So we just have to be comfortable with throwing it out into the public and having people comment on, be like, this is what I don't like about this. This is the usability of it. You don't have enough research on here. And I'm like, yes, I need Jerry Clark to upload all his 30 years of research he's done onto this database. So that's also part of the challenge. But yeah, I mean, just kind of being in contact and in conversation, especially with those crop consultants that work with a lot of farmers. Their perspectives are very necessary and insightful.
Yeah, thanks for sharing. Out of curiosity, raise your hand if you think you are a data scientist. Okay. Raise your hand if you actually work with data, manipulate data pretty regularly. Okay, there's more. I don't know if I am a data scientist or not. I think I can recognize one from afar, but reflecting on my own is like, I don't know. Someone else has to call me that. Maybe our panel also feels that way too. So our next panelist, I think, is also pushing the boundaries of how we typically visualize in that verb data. So I'm very excited to hear what Yesol has to say.
Yeah, all right. So I'm going to share a little bit of my research experience about data visualizations for people with disability. So I can just give you a brief context. I'm a data scientist. I don't know, I can count on that, but I am I'm a data visualization researcher. I'm serving for data visualization community where researchers really interested in how to visualize well, how to visualize effectively. How can we build the tools or algorithms so that people can plug in their data and then see the data more effectively so that they can carry out their analytical task or other tasks and so on. So last decade, needless to say, there's unprecedented amount of data just out there, just collecting every day through like personal device, social device, sensors, and interaction log, and so on. There's so much data out there. And then this community tried to like tackle how can we manage that? How can we visualize that? So you can just simply think about like rows and rows and like columns and data sets versus like a visualizations. That's how powerful visualization is. But then the major limitation of that visualization is like you need to be able to see it. So what about people cannot leverage their visual perception, namely blind and low vision individuals? So some of the researchers in our field, including me, were interested in how can we communicate this data to people who cannot see? The simple way to put this is like, we can't just visualize data, right? We have to use different sensory modalities to actually convey the insights of underlying data. So we often classify the approach with the sensory modality that we're leveraging. So one intuitive way is to use auditory sensors, so auditory signals that you can think of like audio charts. Probably some of you use the like whatever calculator and then they just make a sounds. So the frequency of the audio is mapped to the data, and the pitch can represent the exact data points so that someone who cannot see still can listen to it. Obviously, it's really good to understand a trend because it's easier to detect the different sounds and so on. So it's really strong in conveying those trends and so on, but it has its own limitations. So let's think about line charts with the multiple lines. Then like you have to listen to multiple lines at the same times, then our auditory perception cannot distinguish those lines as well. It's really hard to parse. And also it has like some sequential natures. You can't really see the overview at the same time. So this audio approach has its own pros and cons. So another approach is more of like tactile sensory. So tactile map. Sometimes we use like embossed paper or braille display to actually convey the data visualization through tactile sensory. It's good because like it gives some ownership to the agent that they can actually like navigate all the tactile map by themselves and so on. But it has its own limitation, which is the elements that you're going to put it in the tactile map cannot be too small or too big, and two elements between like two entities has to be separated in some sense because we have our own limitation of tactile sensory as well. It has some, it's good for conveying some topological information. So like you can like move up and down, like it's easier to get sense of those, but it has its own limitations. The next one, which is getting a lot of attention these days, is text. So basically summarization of data because of the advancement of like large language model, people are really putting into thoughts into how can we summarize data well so that people can get the similar amount of information that they can get out of visualizations through this text. And then you can imagine the chart question and answering system where like you can ask a question about the data, then this model or engine can answer your questions and so on. So those are the kind of recent years people put a lot of thoughts into it. So that's been our sort of like community's approach using different modality to convey data. One of the other, I'm talking about mostly from like blind individuals' perspective, who cannot leverage their vision at all. But there's other population who has a visual impairment, namely low vision people who actually have a remaining functional vision. So in our lab, we're interested in like navigating how can we present the different the visualization for them because they do have a remaining functional vision. So we're working on like how to place or how to lay out differently, how to convey the data differently for those who can maximally leverage their remaining vision as well. So I have a few thoughts on where this field hope to go. So those different modalities has been investigated extensively, and it's sort of like one-off fashion. So like, oh yeah, let's do the auditory charts, and then people were like researching around, oh, let's do tactile chart. But what about we merging like audio and tactile at the same time? It's a multi-model approach. But I think it's the field that's mature enough to think about what is the ultimate optimal setup for visualization for someone who cannot see. So what I mean by that is we understand the pros and cons of each modalities, and we understand what people wants to do with the data and what is the context they're in. Are they on the phone? Are they on the desktop? Or do they want to just casually read the data, or do they want to do serious analytical tasks? Considering all of those, we can kind of sort of design an ultimate system that can leverage all different sensory modality as it needs, and then kind of optimize the experience instead of like just getting one modality at a time in one-off fashion research. And another research thread that actually, that's an ongoing future research people are working on. I mainly talked about people with visual impairments, but other disability actually hinder the experience of reading data. So for example, cognitive disability as well as motor disability, because their dexterity, they can't really have a less of dexterity of their hands. So the interactive technique has to accommodate those disability and so on. So I hope to see more of those other disability accommodations in data visualization community.
Yeah, I love that research. While you're going through all your examples, I'm trying to visualize it in my head, and I love this type of research because you're making this so much more accessible for all different sorts of people, but also it makes my brain hurt in a way that is like, it is really pushing my boundaries of what could be done with data. So that's really fascinating. We do have time for plenty of questions. If you all do have questions, you can submit your questions here. While we're talking to Yasol at the moment, I have a question for you. So I feel there's a lot of information gained when you transform just like a standard scatter plot with 2 dimensions into 3 dimensions. Is there an analogous type of quote unquote visualization that you could do without actual the sensation of vision?
So you're saying that is there any analogous version, 3D version?
Yeah.
Without leveraging vision?
Yeah.
Interesting. So, I mean, there's a way to look at your question, yes. So the one, we call it like one dimensionality as a, let's say, channels. So when we talk about 3D, you kind of add one more positional dimensions to this visuals. In audio, there's many channels too. So for example, I talked about frequency or pitch, but there's a volume, there's a length of certain audio clip. There's other channels that you can add to it to encode the one more dimensional of data. So that'll be the equivalent to tactile as well. You can think it as like tactile, the depth of the tactile elements, or like how dense it is, how rough it is. They can be all the one more dimensional to add to encode data.
So cool. Okay, now we're going to transition into questions from everyone here in the audience, and feel free to keep adding. We've got a couple for Will to start. Will, regarding the on-farm database, it seems like it would help to reduce barriers if we provided a platform to make tables, plots interact with the data. And we'll go on to the actual question. Can you give an example of what issues?
Text.
Oh, okay.
I like your question. It's not a question.
So Kyle asks, can you give an example of what issues have been identified and addressed by the farm data analysis? What questions would be answered by searching the database?
So one farmer I work with wants to integrate livestock into more of his cropland. In our farming systems in Wisconsin, we typically have a pretty delineated dairy or livestock, beef, sometimes more dairy system, and then we have a grain system. And it's not never the twain shall meet, but in our grain systems, we don't have a lot of opportunity for livestock integration, which has a lot of benefits to our farming system, including addition of manure and organic matter and fertility, recycling, yada, yada, yada. And so he wants to integrate more livestock onto his cropland by doing something really weird, which is taking his corn rows, which are usually spaced 30 inches apart, spreading it to 60-inch rows. So he's pretty much taking out that middle row and planting, while the corn is growing, a bunch of cover crops in between, which are plants that usually you just plant for taking fertility. But this one, after you harvest the corn in the fall, so you plant it in June, after the corn, harvests the corn off in the fall, and he throws his livestock out there and grazes it with his cattle. And his question is this profitable? And so that's what a lot of what I do is, not a lot of it, part of what I try and bring to it, and something that I ask a lot of the extension faculty in CALS to do is like, okay, this is great, but what's the numbers? How are we approaching this from an economics perspective? Because these folks are running businesses. They don't always know their numbers, which is problematic from the get-go. But, how can we put numbers to this and then use this platform of this on-farm research database to show other farmers that here's why it's not profitable for this moment. Here's what we need to gain in order to do that. And here's the variables that maybe we're thinking about changing for next year. Or here's the variables that you could work on your fields to try and address that. So a lot of it is kind of putting these questions up in the air for other people to latch onto and try it on their own farms. So I kind of hope that answered the question, maybe.
So Kyle continues to ask you, so given that, like, you can share a lot of different interesting ideas with potential competitors. What are the incentives for farmers to actually share their data?
That's one of the things that's kind of nice about this, is that people compete with their neighbors. And so this is something that we've seen throughout extension over the years, is that when you get people from different regions or even from different parts of a county together, they're not necessarily going to be like, oh no, I'm not going to share with you. And we're competing on the world stage because a lot of these are commodity crops. We might have a really bad corn year across the entire corn belt in Wisconsin. I'm not in Wisconsin. Corn belt includes many other states, but we might have a bad year for corn. And so it's like, oh, corn prices are going to be high. Those that did well are going to get good prices. Not true, because we're competing with Argentina. We're competing with Brazil, because now that they're doing a lot more commodity cropping. So competing with your neighbor doesn't really matter, because that commodity price is set in Chicago, which is based off of global commodity prices. So that idea of competition, it's not that it doesn't exist, it's just been globalized. And so I hope farmers start to kind of realize that this could be a collaborative experience, and that you should be feeding off of each other ideas about how can we move things forward, how can we stay on the landscape. That's a big problem with small and medium-sized farms, is how can we stay on the landscape when the thing that is being competitive is land prices. As more land gets taken up for development and other things, it pushes up land prices, and the big farms are able to, leverage more of their farm to buy that land. So that is where the competition comes in, but it's not necessarily on like sharing secrets. But again, that regionality takes people away from their neighbors and maybe makes them a little bit more open to share that. And so I think the database helps to simulate that on a digital scale.
Interesting. We have quite an intriguing question for all the panel. Is anyone today seriously thinking about preserving your data for 5 millennia?
We may be thinking about it, but there are limitations of funding, interest are probably the most important ones. What are we going to do if there is no funding to maintain the systems?
Or, if technology changes, I've seen a lot of, initiatives in museums and things to try to preserve outdated technological formats and things, or revive games that don't run on the systems that exist currently. And, they used something that, literally nobody uses anymore. and so I think about that too, is like, not just the cost and the maintenance, but also the infrastructure to, handle that data. It's like, yeah, the data could still exist, but, it might exist in a place where no one can find it. And then, that I think that's pretty much the same thing as losing it. And yeah, so I'm thinking about it. I don't know if I have any answers, especially as technology is progressing so rapidly. I wonder if you would just have to encode things in infinite formats or something. But I think one thing you can do is be prepared for that. Try to make what you have as interoperable and reusable as possible, to prepare for the future as much as you can. Because yeah, it's I guess hard to predict sometimes what will replace something else and things like that. But if you have some standards in place to make sure that your data is already, publicly available from the get-go, it's in more people's hands, more people can use it and see it and share it. And, that in a way that helps it live on as well. So that's my 2 cents.
So this reminds me of just go back to the Voyager spacecraft, the golden record, which was placed on them, which includes, images, sounds, and data of various kinds. But that was such a one-off kind of project. And I think that on the one hand, there was a desire at that particular moment to preserve for somebody. And another question is, for whom would who's going to be, for whom would it be useful 5,000 years from now, or who would be interested? And of course, this was for, potentially extraterrestrial beings, but to put it into a format that potentially could be read, how to play a record. I mean, it's a record, right? An LP is what I'm saying. But, I recently read about, I don't remember which group this was. It was probably one of these commercial spacecraft where they used some new encoding technology to, I don't know, engrave all of current Google books onto a little silicone wafer. Does anyone know what I'm talking about?
Yeah.
Yeah. But I think that there's this very old idea, which has been gone through many permutations over many centuries in many different cultures, of if we only had everything, it's the total archive dream, right? And if we could just preserve all of that and have total access to everything, that would be the best of all possible worlds, because then you could, in a dream of also, pure induction, you could trawl through it in any way you want. You can manipulate the data for your own contemporary purposes, whatever those happen to be. But in actual fact, I think data sets are always curated in some form or another. There is no total archive, right? And so even today, when we're trying to do our best to preserve, there's always loss at every stage of the game. So, the 5,000 years later is an interesting question, but it's not just issues about what format, what would there be funding to maintain it over the years? Would it be actually readable 5 years? There's all those kinds of questions which diminish the total archive. But even apart from those kinds of pragmatic kinds of limitations on our ability to do so, there's the larger philosophical question of why,
So yesterday I did a workshop and I thought it would be a good idea to maybe record it with video. So I busted out this old video camera that I had from 12 years ago. And I had a 32 gigabyte SD drive, which cost gold essentially between 12 years ago. And it's corrupted. So unfortunately, it's not going to be in the wealth of human knowledge. You have to miss out on all the cat videos that are recorded 12 years ago. Again, for the entire panel, what can the university do to change incentives for academics to promote open research and science?
Yeah, that's a tough question. I think that the way that publishing is structured has been the way it has been for such a long time, that the way that we, produce articles and evaluate them and, measure their impact and all of those things are so tied with the format and, how this ecosystem works. And I think there's been a lot of people in libraries and research support and researchers that are working on, different methods of recording knowledge, non-traditional publishing, putting your dissertation on a website, some things like that. And, how to measure that and how to, evaluate it within the context of, the scholarly publishing endeavor might not be the same. We might have to come up with different metrics for that, or different ideas on how to measure the impact of publishing something openly versus not, and what that means for the research. And it's like, why are we doing that? What is the point? You can see the effects that it has in terms of, being able to share it widely and public access, and, perhaps people across the world and in less well-resourced places being able to, iterate on what you've done and things like that. And I think those are things a part of the research enterprise that isn't necessarily captured in an RTP document or something like that. And, that's something I'm thinking about, and I'm sure a lot of you are thinking about as well, is incentivizing openness, or finding rewards for it in our current structure. And I wonder if there's, a future where we have just kind of a separate set of ways to measure these things or document it. And yeah, that'd be something cool to explore. I know a lot of librarians are thinking about it as a former librarian, thinking about open educational resources as well. I had an open educational resource program where faculty were like, this is the only place I can do this work because we provided a stipend for it. And they're like, this is the only way that we can do this, or we don't, have a method for, being compensated for this labor in our current structure. And so I'm really doing a lot of thinking about how we can include more different types of knowledge production as technology has evolved and science processes are evolving and things like that. And I'm sure everyone else has thoughts too.
I think for us, aside from everything you just mentioned in incentive structure, really important is the reuse of the data. So these LTR sites, which have this wealth of data available to any kind of new researcher coming in, are very attractive because data are infrastructure at that point. So as much as they want to use our boats to get out of the lake, out on the lakes, they also need the data that we've been collecting for now over 40 years to put whatever little bit they can research right now into the larger context. So as soon as data producers also turn into data reusers, the whole perspective of publishing data changes drastically.
Well, Corinna, you were talking last, and we had a question for you specifically. Going back a little bit, when your database initiative was getting started, did you have funding from the beginning, and how did you go about acquiring funding?
There we go. Sorry. Takes a certain touch. The databases, we got that started for other needs, really. So if you run a large natural history collections operation, people need to print labels. And when they print labels, they type that information in already. And so at that point, when somebody comes in and say, I'll just keep that information digitally, that is the beginning of the database. And then there's a lot of these chicken and eggs things happening. If you have more data, you can do more with them. You can then inside your collection, you can say, oh, I've got so many data collected by this person. I have so many specimens. I've got so many specimens of this particular species. And so the interest increases with more data available, and then we got funding.
Excellent. I'm going to actually abandon our Q&A for 1 second to ask one of my own personal ones. Thinking about your area within data science or history, is there a story that you have that you feel really captures the feeling that you have about your field? So I get jazzed looking at people's CT scans and being like, wow, we can take this one scan, multiply that by 140,000 for all these different patients, and then start to think of new normals of what it's like for health from the inside out. I get too excited about that, so I'll stop talking about that now. But passing on the panel, what was the story that you felt like, oh, I know this is the area for me?
Well, this is not a story about what made it clear to me that this was my area, but it's a cool story, so I'll tell it to you anyway. So John Flamsteed, who was the first royal astronomer at Greenwich Observatory in the 1670s, 80s, got into a huge fight with Isaac Newton, who desperately wanted Flamsteed's lunar data for his, among other things, theory of gravity. But Flamsteed was committed to a systematic approach to his own data that he laboriously collected over many, many sleepless nights at Greenwich. And he was compiling his star catalog very assiduously. He wanted it to be the best star catalog, better than Ptolemy's, better than Tycho Brahe's, and so on. So Newton basically went over his head to the Queen of England and got a commission appointed and put his friend Edmund Halley of Halley's Comet in charge of it to investigate Flamsteed for not sharing his data. So they eventually prevailed. Halley got a hold of Flamsteed's data and published it in 1712. Flamsteed was so outraged at the way in which his data had been published and put before the public that he bought as many copies as possible. And as he said, consigned it to, I'm not going to remember the quote. He burned them. I mean, he basically took out the pages that he thought that was okay, that had not been reduced in a way that he found unacceptable, basically. He took out those pages because he thought he could include them in his own printing. And he burned the rest because he objected not just to what we would call, I guess, his intellectual property theft, but because he thought that his data had not been reduced properly. And he then set about publishing his data in the way that he saw fit. He unfortunately died before that happened, but his widow carried the project to conclusion. And the consequence is that the Halley edition is now very rare because there weren't that many copies that Flamsteed didn't manage to burn. But that's I think, an interesting story of data data use and reuse and who has rights to it and whether you owe your funder or the public in general to publish it, but then who has the right to present that in the way that they think best.
So before I started working in agriculture, I was doing kind of more urban sustainability stuff with some nonprofits in southern China, supporting local nonprofits to do kind of capacity building on their different foci within environmental sustainability. One of the groups that we worked with was this business that was working with farmers, rice farmers in northern Guangdong, which is the province that I was in, and working with them to see how can we do more sustainable rice production, and then working with them from a technical standpoint, buying their rice, having facilities in that village to help to keep it in cold storage, and then move it to the cities where they could get the higher price for it. So compensating farmers for their extra labor and that kind of inputs while also, running a business. And so in working with this group, it was just, where was I going with this? Oh no, I had a story.
Something you're obviously really passionate about?
Yeah, something I was obviously really passionate about. And now it just flew like a butterfly from my mind. Shoot.
I don't know.
Yeah, I'll just burst into someone else talking when they tell their story and I'll remember.
I can go next. Ben, you make me reflecting on my entire life. Like why am I here? So I think it's really about my undergraduate experience. I majored in statistics. And then my life is really different before and after knowing statistics. Per se, my life was really complicated in high school and college as a college student. Then knowing about kind of quantifying, modeling makes me think that life can be really sort of simpler. And then it's kind of powerful because you can kind of stick to the number and then decision kind of came out from that model. That idea was really fascinating. Obviously, the modeling is not simple. Anything is not really simple. But I think I was really passionate about understanding the number and how can we use the statistic or modeling or data as a lens to look at the world and then make my own decisions and so on. From there, I try to communicate this with my parents, how excited I am, but that was definitely not the easiest task at all. So I think from there, I just developed my passion through how can we communicate this? How can we communicate this with the lay people or your parents, grandparents, and so on? So I think I kind of knew back then I need to work on this field.
I remember. It's not going to be climactic at all. It's going to definitely be okay, whatever. How'd you forget about that? So I was working with these farmers and I was like, okay, this is really cool. I want to work in agriculture. What's my next step? I need to kind of see if this type of world is what I want to work in. So I moved to a different part of China and was kind of doing a needs assessment of organic agriculture in this very kind of hippie part of China in Yunnan province. But And in talking with farmers, I was like, okay, how do I approach these people that are just in their fields? Like, I'm this white dude, like walking around and where there's not many foreigners. Like, I don't want to be a total weirdo. And then I realized I was like, okay, everyone's smoking in their fields. So I'd approach them with a cigarette and I'd smoke a cigarette with them, sitting there and talking with them about their agricultural systems. And I was like, this is what I want to do. What job can I do where I can just sit and smoke a cigarette with a farmer and chat about life? So that's not what I do. I do other things, but it's part of it.
And we don't endorse smoking.
Yes, no endorsement.
Endorse smoking.
But it's good for, greasing social wheels sometimes in China.
Yeah, that button is tricky. I guess I can go next. I think a pivotal moment for me was when I was an English major, as many librarians are. And I took a rhetoric and digital media class that really changed my perspective on how technology functions in literature and the humanities. And I was like looking at, digital text exhibits and, digital novels and things from Asia and all kinds of media and different, perspectives represented in digital formats. And I was like, wow, this is really cool. Like I love seeing how people express themselves through technology. And, that led me to, digital scholarship, digital humanities, things like that. And I was like, oh, who's doing that? Oh, it's librarians. So I went to library school and I worked in a digital scholarship center, which is now called the Open Knowledge Center, where I really got introduced to a lot of concepts around how a lot of this digital work in digital humanities and digital scholarship, the ethos of it is to be publicly available, to be something that people can come to, kind of like a digital museum exhibit. A lot of museums are free and they have exhibits, and the same would go for these works online. And I started really getting into looking at different DH projects and digitally represented histories, and it's like, well, this is fascinating. And so I was continuing to do work at the Open Knowledge Center, and I realized I really wanted to make a career out of this, and I became a scholarly communications librarian. And I also just really love hearing what people are researching and what they're doing, even if I don't understand. I just think it's really cool to just see what people are investigating and what they publish. And so just having that endless curiosity combined with this fascination of, how technology supports different means of knowledge production really led me to librarianship and supporting that in a library context. And then, there aren't a lot of open source program offices in America. There's only a few. And so I knew this was a really amazing opportunity to come here and be on the sort of the cutting edge in academia of all of these concepts that I've really enjoyed being a part of throughout my career. And so I came to Wisconsin from North Carolina, and I've been really enjoying it here so far, and starting up this office in the Data Science Institute to really advance these concepts of how technology is used in research in a really interdisciplinary way. So yeah, super happy to be here. It's great. And at this bazaar as well to hear what everyone's working on. Like if all of my work days could just be a conference, I would love that. Maybe you wouldn't, but I would.
Well, thanks for being here and welcome. I didn't do anything about your decision coming here, but glad you're here. Corinna?
Thank you. I honestly don't really know how I got there. I have a PhD in botany, and that is my passion. And data, I think I just had the vision of what you could do with them way back when. And that in combination with it not being very easy to find a professorship as a woman in the department where my husband worked, led me down the path of a second choice career. I can't say that I didn't enjoy it. I have done a lot of things that were really good.
Excellent. Yeah, thanks for sharing. Well, Oh, we have 5 minutes. If we got maybe got a bonus turning point faster question. I think this is a very great closing question for the panel, and I'll say you've got 60 seconds to answer this each. That's fine. It's an easy question. What can the UW learn from 175 years of using data and research moving forward? Again, super easy. You got 60 seconds if anyone wants to dive in.
I guess I can start with the completely new person perspective. I was walking around WID, and there's a bunch of research timelines on the walls and things of like milestones that have happened here and major discoveries and things. And it's, really, really inspiring. Maybe that's cheesy, but I found it really inspiring to see all of the advances that have happened specifically here and in Wisconsin as well. And what really struck me was the idea of the Wisconsin idea. And I really appreciate that, that's sort of put into words and really crystallized in that way here, because I think it's such a guiding light for what has happened here. You can see the benefits that everything from the past has had in the world and Wisconsin and everywhere, and people are continuing that legacy here and operating under the Wisconsin idea, and really making sure that their discoveries are benefiting beyond the campus borders. And so that was an ethos that I really resonated with as I was visiting here for the first time, and also like, oh wow, SPF was developed here. Whoa, being able to connect things that you use in your daily life or see around or you've heard of to a place, I think is also really powerful. And so I've been really enjoying learning about that rich legacy of innovation here, and happy to be a part of it moving forward. I'm sorry that was longer than 60 seconds.
Piggybacking off of the Wisconsin idea part of it, because extension is a big part of that. At least I think it is. And what Sol does is design, I think, is a big part of that. If we want it to be usable to folks, not just in academia, not that that's a bad way for data to be, but to be publicly accessible, to be usable by folks, farmers, whoever it is, out in the world beyond academia, design, and how do we represent data? How do we, even design the framework in which it habitates? How do we do that as a way that makes it more accessible for people that are, accessibility impaired, for folks that, are just lay people who may not be able to manipulate data in the way that folks in academia just are trained and know how to. So moving forward, if we want to take that Wisconsin idea into the future, I think that's a big part of it.
Piggyback on that. We were talking about this Wisconsin idea for before starting this panel, but yeah, I agree that application and outreach efforts would be definitely the way forward. I'm more and more interested in how can we actually design for people who can actually use it versus just publish within a community and just share within a community and so on. So moving forward, that'll be really interesting way forward.
Go for it.
So I think what came to mind when you asked that question was the Dictionary of American Regional English, which was a project that was based here in UW-Madison in the 1960s. Basically field work to send teams of researchers across the U.S. to document how people spoke. The survey instrument was incredibly long and included a lot of questions about what do you call a female animal of X or Y. A lot of documentation of rural and agricultural and husbandry kinds of practices that we don't necessarily have access to. The reason I think of it is because it's a project which really brings together. It was funded by the Department of Education, but it had direct application in many different respects, from agriculture and economics and other areas, and also into forensics when they identified someone who kidnapped someone, who wrote on their kidnapping note, deliver the ransom note and put it on I forget what they call it, the devil strip, the terrace, the parking, the boulevard, the piece of grass in between the sidewalk and the road. But it's a project that really combines all disciplines, right? From data science to humanities to social sciences and so on. So I think my word for data science here at UW would be that it's holistic and disciplinary wise.
All right, Corinna, you have the last word.
Oh, that's dangerous. I think I'll pick up on the holistic. I think we still need to do a lot more inclusivity work and even broaden our idea of what are data, what do we consider to be data, and how do we use them, and how can we move on. I'm still amazed on how little impact the data have in our daily life, and I hope that's going to change sometime. It has not yet, I think.
Yeah, humans are complicated. I don't know if anyone has known that or noticed it. But we are at time. So I want to thank our panel very much. And if everyone can join me. So thank you all for coming. They're wonderful, lovely human beings. You want to come talk to them. Thank you all for joining the Research Bazaar in its 5th iteration. And hopefully it won't be the last. And thanks to all of our sponsors and support. I guess we are done. But remember, your collaboration stories with other people don't end here. You are in a room full of amazing, wonderful people. You never know who's going to have stories about vengeful data stealing or kidnapping. It could be right around the corner from you. So thanks again for everyone attending, and get home safe.